find all solutions to the non-homogeneous linear ODE, y prime minus 3y equals b of x, where part 1, b of x is equal to e to the x, part 2, b of x is equal to x, and part 3, b of x is equal to cosine x. What's our procedure? First, we're going to solve the homogeneous equation, so that's where b of x is equal to 0. The solution that comes out of that we'll call y. Then, to solve the non-homogeneous equation, we're going to take a function u, multiply it by y, put it into the non-homogeneous equation, see what comes out. It'll be a differential equation for u, and then we'll solve that and see what happens in each special case. So, first, let's solve solution for y in the homogeneous case. So, we'll assume y is of the form e to the rx, and then we'll see what happens when we put e to the rx into our equation. So, take its derivative. Derivative of e to the rx is just going to be, you return e to the rx, okay, we have exponential to a function, and then multiply by the derivative of that function. So derivative of rx is just going to be r. Put that into our differential equation, okay, homogeneous one. That's going to give me e to the rx times r minus 3 is 0. So since e to the rx is never equal to 0, we're going to have r equal to 3, and our solution for the homogeneous equation is going to be y equal to e to the 3x. Now, we take that equation, multiply it by a function u, stick it back into the non-homogeneous equation. What happens here? So we're going to take the derivative of, okay, u times y is going to be u times e to the 3x. So we're just going to compute what happens when we put it through here. So when I take the derivative, it's going to be a product rule and a chain rule. So product rule says u prime e to the 3x plus u times the derivative of e to the 3x. So that's 3 e to the 3x. Okay, minus 3y, so that's u e to the 3x. That's going to be equal to b of x. So what you'll notice is, okay, the first term stays as it is, and then the next two terms cancel out, leaving me equal to b of x. So that means u prime is equal to b of x over e to the 3x, or b of x times e to the minus 3x. So now let's put in our specific values for b. So if b is equal to e to the x, then u prime is going to be equal to e to the minus 2x. So to get to u, I just take the antiderivative. That's going to give me, well, what do? We're going to take the minus 2, flip it over, and then just return the exponential. So we'll get this plus a constant c. So my solutions are just going to be u times y. That's going to give me this. Okay, and you'll note, okay, when you clean things up, what are we going to have? We're going to have minus a half e to the x plus c e to the 3x. One thing that's good about this, okay, we see that our homogeneous solution shows up in the second term. So that's the e to the 3x with a constant attached to it. Now, of course, we want to check our work, so let's see what happens. So if I just push it back through our differential equation, okay, the non-homogeneous one, you'll note as you work it out, everything's going to cancel except for an e to the x, and that's what I want for b of x, so that works. Next part, b of x equals x. So our u prime equals x times e to the minus 3x. We want to take the antiderivative of this. That's going to be an integration by parts. So what happens? We let w be equal to x, dv equal to e to the minus 3x dx, then dw is equal to dx, and v is equal to, okay, we take the antiderivative, that minus 3, we flip it over, and then I have e to the minus 3x. So rule for integration by parts, multiply down the diagonal, multiply up, take the difference, and then integrate the second part. So what happens? So we'll have minus x over 3, e to the minus 3x, then minus a minus 1/3 antiderivative of e to the minus 3x. So antiderivative of this is going to be, take your minus 3, flip it over, leave the rest alone. So I wind up with minus x over 3, e to the minus 3x, minus a ninth, e to the minus 3x, plus a constant. Don't forget your constant. That's going to bring out our homogeneous solution. Now, we just take our solution here, multiply by y, which is e to the 3x. So that's going to take out these e to the minus 3x's. So I'll have minus x over 3 minus 1/9 plus c times e to the 3x. And then we see here, the homogeneous solution comes right out. Check. So I just take the derivative of this and then subtract off 3 times this. When I do that, what's left over is x, and that's going to be my b of x. Last part, b of x is equal to cosine x. U prime equals cosine x times e to the minus 3x. We want the antiderivative of this. You have 3 options. One is you do the double integration by parts and just grind it out, or you could just look it up. Or later on, we'll have a method using ODEs that's going to let us reconstruct this when we know what ODE this guy satisfies. For now, we'll just pretend we looked it up. So what's the rule? The rule is you identify the coefficient in your e to the x, so it's going to be a minus 3. The coefficient for x in your cosine x, so here it's going to be a 1. Take the sum of their squares, we divide by those. Coefficient in your exponential goes in front of the cosine term. Coefficient in front of your cosine goes in front of the sine term, and then add them, add on your constant of integration. Okay, if I want solution to our non-homogeneous ODE, we multiply by our e to the 3x, and that's going to give me minus 3/10 cosine x plus 1/10 sine x plus c times e to the 3x, and again, homogeneous solution showing up right here. We check, so I just take the derivative of this, subtract off minus 3 times this, and we know what comes out. That's just going to be cosine x as promised.